Okay, so here we go today with 1.3, section 1.3, and this is going to be solving equations with variables on both sides. And when I say both sides, I'm talking about both sides of an equal sign. There's really no definitions or vocab that we need to go over with this. We'll be using stuff that we've had before. So we're just going to start with some examples. So first example here. 10 subtract 4x is equal to negative 9x. The difference between this equation and what we have done thus far is now I have variables on both sides. We still need to get these x's together and isolate that variable. We need to get it on one side of the equation and the other. And in order to do that, we're going to use inverse operations just like we were doing before. So I can see right here, I'm going to investigate kind of what's going on in here. If this 4x was over here, this negative 4x was over here, I'd have my variable on one side of the equation and I could solve. So what I'm going to do is instead of moving this 9x over, I'm just going to add 4x. My 10 stays, that's 0. That's what I'm looking for. Negative 9 plus 4. Negative 9x plus 4 gives me a negative 5x. X is being multiplied by negative 5. I reverse that or undo that multiplication by division. Positive divided by a negative is going to be a negative answer. 10 divided by 5 is negative 2. 10 divided by a negative 5 is negative 2. And that's what x equals. Or if you prefer, you can have x equals negative 2. And you could say, hey, Mr. DeLong, couldn't I move that 9x over first? And you could. And here's what happens, though. You're actually going to end up making more work for yourself. Because if I add 9x, now I'm going to have my variables on both sides, but I still have this 10, which I'm going to have to move over. And I'm just going to do this out because I'm going to show you what happens. 10, negative 4 plus 9 is 5, and I've got my x there. Negative 9x plus 9x, and this for some reason creates some issues sometimes. Anything subtract itself, these are inverse operations. If I have the same thing and I add it and subtract it, my result is always going to be 0. And I will see 1 here as this answer. I will see it left blank, but this is 0. And now I need to subtract 10, and I get 5x is equal to negative 10. X then would equal, if I divide by 5, x would equal negative 2. So you can see I get the same answer, but a lot more steps involved right here, and a lot more potential for error. I'm going to box in this answer as negative 2. You could always check it. 10 minus 4 times negative 2. Negative 2 times negative 4 would be positive 8. 10 plus 8 is 18. Negative 9 times negative 2, positive 18. That checks out, and I'll box in my answer. You are going to run into problems that look like this. 3 times the quantity, 3x subtract 4, is equal to 1/4 times 32x plus 56. Now, first thing that we looked at last time in 1.2 is I'm going to look to see if I can simplify on both sides of the equation first. And I certainly can simplify both of this. I can already see that I'm going to have to distribute on both sides, and I'm going to have variables on both sides. So there's a fair amount of steps that are going to be involved in this one. But my first step is going to be to distribute. Follow my arrows. 3 times 3x gives me a 9x. 3 times negative 4 gives me a negative 12 is equal to 32x times 1/4, or 32 dividing by 4, because multiplying by a fourth, is just like dividing by 4. 32x divided by 4 would give me an 8x. 1/4 of 56, or 1/4 times 56, or 56 divided by 4, leaves me with a positive 14. All I did was distribute right there. Now I'm right back to where I was up here. I've got variables on both sides of the equation. I'm left with a choice of what to do. And I'm going to think this through before I move ahead. I really don't like dealing with negative variables. I can certainly handle it. But whenever I have variables on both sides of the equation, I always think to myself, how could I make this a little bit simpler? How could I even keep my variable positive? Well, 9 is positive and it's bigger than 8, and I can see right now if I move using inverse operations this 8x over, 9 minus 8 is going to give me a 1x. My variable is going to be on the left. I like doing this first, and you certainly could have subtracted 9x first. I just chose not to. 9x minus 8x leaves me with x, and I have subtract 12 is equal to, that's 0, 14. Now just a simple one-step equation. X is being subtracted by 12, so I add 12. X then would equal 14 plus 12, which is 26. You can certainly go back in and check that in the original equation if you would like. I am going to choose not to. I'm going to box that in and hope it's right. Next one right here. 1/2 times the quantity, 6h, subtract 4 is equal to a negative 5h plus 1. Go ahead and pause the video for a second. After you have that written down, give it a whirl, and then come back in a minute and see what we got. Go ahead and take a pause and work it out. All right. Here's how I'm going to solve this. I can see I'm going to take a look first. I'm going to have some distribution, and then I'm going to definitely have variables on both sides. I need to take 1/2 of 6h, or divide 6h by 2. 6h divided by 2 leaves me with a 3h. 1/2 times a negative 4, or negative 4 divided by 2, leaves me with a negative 2, is equal to negative 5h plus 1. Again, I'm going to look at this and kind of think it through. I can see right here, this is a negative 5h. If I add it over here, I'm going to have a positive variable, and I like positive variables. So I'm going to choose to add 5h first. No, you don't have to work with your variable first. I just am choosing to do that, and I'm going to be consistent in the way that I do that. 3h plus 5h is 8h. Subtract 2 is equal to positive 1. 8h minus 2 is equal to 1. H is being multiplied by 8, subtracted by 2. I need to undo those or reverse them. So I'm going to add 2. What I do to one side, I must do to the other. 8h is equal to 3. I divide both sides by 8. H is equal to 3/8. I think to myself, can 3/8 be reduced? It cannot, it's simplified. Yes, you will sometimes get fractions. Yes, you can absolutely plug that back into your calculator and check it. I'm going to trust my work. I'm going to box that in and say H is equal to positive 3/8, excuse me. So that's that's solving equations with variables on both sides. I'm going to flip my paper over and start a new page of notes. It's just a continuation of what we have going on, because sometimes when I have variables on both sides of an equation, special situations come up. So we need to take a look at those, and I'm just going to title this Special Solutions of Linear Equations. All these we're dealing with are going to be linear, meaning if I look at them on a graph, they will make a line. Here's the first example. 3 times 5x plus 2 is equal to 15x. So again, if I look at this and think it through, I know I'm going to have variables on both sides. I've got some distribution to do. 3 times 5x, 15x. 3 times a positive 2, positive 6, is equal to 15x. Now, I can see something right away that's going to happen. I have the same coefficient, the same number in front of the variable, with the same variable on both sides of the equation. So something interesting is going to happen here. Doesn't matter which side I move the variable to. If I subtract 15x from both sides, hopefully we can see right now what's going to happen. This will be gone because it will be 0. 6 then is going to equal, and that is 0, 0. My variable disappears. It goes away. By using inverse operation, I lose my variable on both sides, and I'm left with this. 6 is equal to 0. I just need to evaluate this as a statement. Ask yourself, is 6 equal to 0? It certainly isn't. I'm going to say that's false. This little symbol right here, these 3 dots, means therefore. And I'm just going to say false. Therefore, this equation has no solution. Has no solution because my variable disappeared and I got a false statement. This is the answer that we need to present. It has no solution. And that makes sense because if I look at this right here, I'm going to rewrite it. 15x plus 6 is equal to 15x. Remember, for an equation to have a solution, I need to be able to plug in a number for the variable and get a true statement. And I can see right now, it doesn't matter what value of x I choose. I could choose x is equal to 0. If x is equal to 0, this would go away, this would go away because 15 times 0 is 0, and I would be left with 6 equal to 0. That is not true. If I took another value, let's say I plugged in 1 for x, 15 times 1 would be 15. 15 plus 6 is 21. And that would have to equal 15 times 1, which would equal 15. Does 21 equal 15? Certainly does not. Those are false statements. That is not true. That tells me it's no solution. There is no value for x, no matter what the number, that I can plug in for it and get a true statement. Get a solution for it. Next example. Negative 2 times the quantity of 4y plus 1 is equal to negative 8y subtract 2. And again, I can see I'm going to have variables on both sides. I'm going to have to do some distribution, so I'm going to take care of that first. Negative 2 times a positive 4y gives me a negative 8y. Negative 2 times a positive 1 is negative 2. And that is going to equal negative 8y subtract 2. Now from this step here, I hope your intuition is kicking in. What do I notice about both sides of this equation? To me, when I look at it, they look exactly the same. I have negative 8y subtract 2 is equal to negative 8y subtract 2. Something interesting happens here. Let's say I didn't pick that up right away and I just said, you know what, I'm going to move this 8y by adding 8y. The same thing is going to happen, which happened in our first example. Your variable disappears, or it goes away. And you are left with negative 2 is equal to negative 2. A little bit different than what we had up here. 6 definitely does not equal 0. Here, negative 2 absolutely equals negative 2. This is a true statement. Therefore, and you will see this is called, you'll see it's called an identity. But I want you guys to say this, when this happens and I get a true statement, this has infinitely many solutions. Infinitely many solutions. You can abbreviate this as IMS, so we don't have to write it over and over and over. You can write infinitely many solutions. You could write IMS. I would take identity. And again, this should make sense that I would have infinitely many solutions, because in order to be a solution to the equation, I need to be able to plug in any number for that variable and get a true statement. And I can see these are exactly the same. So it doesn't matter the value that I choose for y. Whichever number I choose and put in, I'm always going to multiply it by negative 8 and always subtract 2. And that's always going to give me a true statement. It's never not going to be the same on both sides. Hence, infinitely many solutions. Next example. 3 times the quantity 2a subtract 2 is equal to 2 times the quantity 3a subtract 3. Go ahead and pause the video a second. Give yourself a minute or so, 2 minutes, to try it and come back and see what I got. First thing I see on this is these are very similar, but they're not exactly the same. I definitely have to distribute, and I have to do that on both sides. 3 times 2a, 6a, 3 times negative 2, negative 6, 2 times 3a, 6a, 2 times negative 3, negative 6. Hopefully you noticed right away that these are the same on both sides of the equation. And if you happen to not see that and just subtract 6a, and your variable disappears on both sides of the equation, and you are left with a statement that is true, negative 6 does indeed equal negative 6, I know right away this is an identity. This has infinitely many solutions. There is no value for a that I can plug in. I could plug in 5 billion. I'm always going to multiply 5 billion by 6 and subtract 6, which is going to give me the same on both sides. So there's no value of a. That will not satisfy this equation. Last example I would like you to try. 6m minus m is equal to 5/6 times the quantity 6m minus 10. Go ahead and pause the video. Take a minute or two. Come back and see if you got what I got. Now when I look at this one, it's kind of taken into what we did the other day. I always look to simplify on both sides of the equation first, and I can see right here that I've got some like terms on the left, and I'm going to have to do some distribution here on the right. So 6m subtract m, or 6m minus 1m, leaves me with 5m. 5/6 times 6m. Well, this is just 5/6 times 6, or 6 over 1, My 6's divide into each other, leaving me with just a 5m. And then I have 5 6 times negative 10. 5 6 times negative 10. Well, now I can see I'm going to have some sort of fraction. Common factor, greatest common factor between 6 and negative 10, 2. So I can simplify that to a 3, that to a negative 5. 5 times negative 5 would be a negative 25. 3 times 1, that's just 3. So I'm left with negative 25 thirds, or subtract 25 thirds. Now hopefully you are seeing that I am going to have this, I've got this exact same coefficient and variable on both sides of the equation. Doesn't matter what I do, because if I subtract 5m from both sides, this becomes 0. Remember, anything subtract itself is 0. That's 0, and I'm left with negative 25 thirds. 0 does not equal negative 25 thirds. That is a false statement. This has no solution. And there we have section 1.3 with variables on both sides, and then some special cases that go along with that. Give those practice problems a try, and we'll get back together and go over them.